All right, I just wanted to do a quick review of the things that we had talked about before we were sent home. We had been working on Unit 5, which dealt with similar triangles. And in similar triangles, we know that we have congruent angles and proportional sides. We wrote lots of proportions and solved lots of proportions to find missing measures. Then we did an activity on right triangles where you had to measure all the sides of these triangles and write ratios comparing certain ones. And when we did that, we found out that the ratios were always the same, which led us into talking about sine, cosine, and tangent, the three basic trig functions that we're going to concentrate on in Unit 6. And we always use those with right triangles. Right before we were sent home, we were working on identifying the opposite and adjacent sides of a right triangle, as well as the hypotenuse in the right triangle. I underlined the TOA part of SOHCAHTOA because that is where we are going to start our time working on that trig ratio first. So somewhat new material. You're going to be able to write the tangent ratio for any angle that's given to you. Keep in mind, we do not write trig ratios for the right angles in the triangles. It's always for the acute angles. When I write a ratio for a trig function, I will decide what ratio I need to use. In this section, we're always going to be using tangent. We're going to practice each of the trig functions individually before we work on deciding on our own which one is going to be most useful. So I start with the trig function and the angle that I'm concentrating on. This is theta, which stands for, which is a letter of the Greek alphabet. And the tangent ratio always compares the opposite side to the adjacent side, making sure that opposite is always in the numerator. Sorry, my dog. So if I'm looking at a right triangle and I want to write a ratio for the tangent of angle A, in order to do that, I have to know what side is opposite of angle A and what side is adjacent to angle A. One thing about the tangent function, it doesn't use the hypotenuse. So we know that whenever we're writing a tangent ratio, we're not going to use the value of the hypotenuse in our ratio at all. So for these two triangles, I will not be using the number 13 in my ratios because that's the hypotenuse, and the tangent function does not use the hypotenuse. So for angle A, I just identified this as the hypotenuse. Opposite of angle A is down here, the side that's marked with a measurement of 12. And that leaves the 5 to be the adjacent side for angle A. So now if I want to complete the ratio down here, the proportion for angle A, I would put the 12 in the numerator and the 5 in the denominator, and I just wrote the ratio for the tangent of angle A. Now, coming over here, I'm concentrating on angle B this time. So angle B is my important angle. 13 is still the hypotenuse. And this time, opposite of angle B is the 5. And adjacent to angle B is going to be the 12. So when I write my trig ratio, I'm going to have the opposite side on top, which is the 5, the adjacent side on the bottom, which is the 12, and the tangent of angle B is 5/12. One thing you might notice about these two trig ratios is that they're reciprocals of each other. And they're reciprocals of each other because the two angles that I concentrated on, I don't have measures for them, but I know that those two angles are complements of each other. They're in the same right triangle, and since this is 90 degrees, these two measures, measure of angle A and the measure of angle B, have to add up to 90 degrees as well. So whenever you find the trig ratio, the same trig ratio of complementary angles, you should find out that the ratios are reciprocals of each other. Same thing should happen when I come over here and find the trig ratio, the tangent ratio for angle A and the tangent ratio for angle B. I should find out that those two tangent values are reciprocals of one another. So if I'm concentrating on angle A first, 10 is the hypotenuse, so I know I won't use the 10 in any of these trig ratios. Opposite of angle A is the side whose measure is 6. And I'm not going to write opposite there this time because I know in my next problem I'm switching to angle B, and that's going to switch which side is which. So opposite of angle A is the side that has the measure of 6. Adjacent is the 8, and the tangent of angle A is 6/8. But when I simplify that, it simplifies to 3/4. Now I want to find the tangent of angle B. So my angle that I'm concentrating on switches. 10 is still the hypotenuse, but opposite of angle B is the side that's measured 8. Adjacent must be the 6. So the tangent of angle B is 8/6, but when I simplify, I will have 4/3. And again, those two trig ratios are reciprocals of each other because angle A and angle B are complements to one another. Now you'll have some time to practice writing tangent ratios.